So anyways, I was telling and the video stopped in between. So now we will see next same kind of set of questions. So let's see this question. Okay, GATE 2003 1 mark question. So consider the set sigma star. Sigma star is set of all strings. Okay, we will see this about this more in TOC. If you know TOC, it's okay. Even if you don't know, this much of trouble. So set of all strings possible. Okay, all strings over the alphabet sigma. Here are the two elements 0 and 1. Sigma star with concatenation operator. So now it is given as concatenation operator. So it can be written as star anyways. So yeah, our binary operator here is concatenation for strings. Okay. So now we have to find out doesn't form a group, non-commutative, etc, etc. Okay. So basically let's start with algebraic structure. So algebraic structure or not. So since it is set of all strings, so this is the set. Okay, set of all strings it is given, and the over 0 and 1, so it will be always be closed. Okay, so it is algebraic structure. So next is this associativity. Okay, so associativity will be holding, because if you take A dot B, anything like something A dot B dot C, A dot B dot C. So anyways, if you are concatenating a string, okay, so it is okay, so this will hold. So you can say that this is associative, and hence this is semi group. So now next is monoid or not. So in case of this, here this epsilon is our E, identity element. So identity element can be epsilon. Okay, so hence it is monoid. So here epsilon is our identity element, so means null. Okay, so now group or not. So see, we have to find out inverse is exist. So it means, let's say some is there, if we take the inverse of it, if it is getting back this identity element epsilon, but this is not practically possible in case of concatenation over a string. So this is not possible. Okay, so group is not forming. Till monoid it's okay, but group is not possible. So hence abelian group is, I don't have to check, because it is not only group. So further going on is no necessity. So now I can say that this is up till monoid is correct, so does not form a group. This is actually correct. Okay, let's see the other options. Forms a non-commutative group, so not, this is false. Does not have right identity element. Obviously it does have a right identity element. Here epsilon is there. Forms a group, so obviously it is false, no need of checking. So option A is correct, so does not form a group. So if we take the element and take the inverse of it, we cannot come back and say that we are after concatenating something with something, you cannot just get nothing. Okay, so means this is a concatenation of strings. Okay, so strings, if you are concatenating with something, already something is present, and you are concatenating with another string, so maybe it's inverse, but we cannot get means epsilon, you cannot get epsilon back. Okay, so this is group is not possible, so up till monoid it's possible. So this is a really interesting question. Okay, so it may look big, but it is a really interesting question. I felt it is a good question. Okay, so now it was asked in GATE 2004 2 marks question. So now the following is incomplete operation table of a 4 element group. Okay, so now this is an incomplete table is given. So let's say this is all the places we have to fill it out, and we have to find out the last row of the table. So this row we have to find out, this one. Okay, so now let's do one by one. So now let's say, so all these are blank. Okay, so now you have to find out, see, first one is E, is the identity element. We can say that we can see, if we take this row, total this whole thing is copied here. Again, if we start seeing this, see, if we take this row, if we see this whole thing is copied as it is from this row to this row. Again, if we take this column, so it will be copied as it is. So since it is an identity element, let's say, so So this is B, this is C. Okay, so now we have to fill out other places. So 6 places are still left. So now here if we try to find out, see that A star C is E. So A star C is E, is present. Okay, so if we check this row and this column, it is coming as A star C is E. So it will be C star A will also be E. Okay, since it is a group, it is already mentioned. Okay, so it is very important to notice that it is also already a group. So now let's see. So C star A will be E. Okay, so now next we have to fill up all these places. C star A is E. So now here you can check already A, B, C, E. Okay, so this is E are already present. So only option, only that for element which is missing in all this is C. So we put C here. Okay, so now we have to check this too. If we start checking this row here, either I can put AE or we can put EA. So let's check the option one by one. Okay, one second. So now once again I just rushed here. So here A star C is E. Okay, so see, if we let's say this is the inverse of A and we are getting E because it is group. So I was thinking like an abelian group, so it's not. So here A, let's say this is the inverse of A and we are getting E. So you can take the other way round also. Okay, so A star C is E means if we take this, it's a group. If we take the inverse of something A, it is giving E. So if we change the orientation, it will still be same. Okay, so now the first thing, let's say here we put AE. Okay, so up till this was done. So now here two options are there. So either I put AE or we put EA. So if we put AE, see in this column, check this. Okay, so in this column, this part from these are headers. Okay, so CEE, double E are coming. So double E are coming. So this is not possible. So this orientation is not possible. So the other way down is possible. So it is EA. So now next is CE is done. So A and B are left. So we can write it as AB. Okay, so if we would have written like this, B and A, it would have been false because see, two A's are coming and in this column two B's are coming. So this is not happening. So this is B and this is A and this is B. Okay, CEAB is our last row. So the last row of the table is CAEB. One second, let me check the answer. Oh sorry, I don't know why maybe it's more than midnight and I'm working whole day. So why I was checking this, I don't know. So this is the correct answer. Okay, option D, CEAB is the correct answer. So CEAB. Okay, so this orientation is very important. So in this way you write. So I'm asking the last row. I hope this is an interesting question. Okay, so it's not tough, it's just an interesting question. You have to find one by one. So this type of question we have already seen, but since I thought let's make the most of it, let's practice more. So you can just pause the video and do the question. Okay, so here let's say 2005 2 marks question. Okay, consider the set of set H of all 3 cross 3 matrices of the type. Okay, so this is basically upper triangular matrix. Okay, so upper triangular matrix and everything we will do in then this linear algebra, but here anyways I will just giving you the gist. So if you see this this part, okay, so only upper portion of the matrix all the elements are present and the lower portion is 0. So this is upper triangular matrix. Okay, matrix and determinant will be ABC. Okay, so now where A, B, C, D, E, F are real numbers and ABC is not equals to 0. So ABC is not equals to 0, it is saying that it is non-singular, hence this is inverse exists. Okay, exist, I don't know what. So this is basically giving you that ABC is not equals to 0. Here our determinant will be ABC. Okay, determinant will be ABC, and which is not equals to 0, and since it is, then it is non-singular, hence inverse exists. So now under the matrix multiplication of operation, the set is H is. So now first we have to check this is algebraic structure or not. Since it is an upper triangular matrix, it will always be closed inside it, everything will always be present. Now next is this semigroup. So if we take associativity, it will hold, because if we take 3 matrices and multiply in this way or in this way, it will give you the same answer. So it is associative. Next is monoid. So identity matrix, I have already told you identity matrix is there. So this is monoid, and here we have already seen inverse exists. So this is basically group. Okay, but this commutative will not hold, so this is not abelian group. So this is basically only the first option is correct. The is a group, monoid but not group, semi group but not monoid, neither group nor monoid. So all these are false. Okay, so it is group. So we have already seen this. I thought if let's take some more for practice. Okay.